can see on the screen we have this structure, right, with an oxygen bond here, right, with just a bond. This is CH3. So this is methoxy benzene. It has the ether group. The ether group is this. You can see over here, this is 1R and this is the other R. Okay, so this is one alkyl group, which is phenyl, and this is another alkyl group, which is methyl. So we can name this compound to be methyl phenyl ether. So that's the name of this compound. Okay, so that's by the way. Let's go into the reaction mechanism. It's a simple one for this reaction, so we could get to know what the product is. So there we have it. So this is methyl phenyl ether. It's also called anisole. Anisole is spelled this way. Alright, it's more like a product name, okay? Methyl phenyl ether, or you can call it methoxy benzene. So this reaction is with hydrogen iodide plus hydrogen iodide. We want to know what the reaction is going to give us. In the first instance, you look closely, you get to see we have an oxygen with non-bonding pairs of electrons, 2 of them, right? So what basically happens is that oxygen is more electronegative than carbon, so it's going to withdraw the bonding electrons of carbon, right? So we're basically going to have a heterolytic bond breakage, that's total withdrawal, right? So once that happens, it's going to give us this. We can have the product here. It's going to give us this, right? Then we have the oxygen. Remember what this arrow means, that is taking up the whole bonding electron. So we are going to have it residing here with the non-bonding electron in the initial structure. Okay, then that means we are going to be generating a leaving group. This guy is going to get kicked out, so we're going to have plus CH3 plus, right, because it's not deficient of its bonding electrons. So basically these are what we're going to have. Now to make this more simpler, let's look at the second reagent here, hydrogen iodide. Okay, so what will happen to hydrogen iodide? This is hydrogen iodide. Iodine is more electronegative, withdraws 8 bonding electron. So we're going to have a proton and an iodide that is very nucleophilic. Alright, now the next thing is that this electron rich area is going to pick up this proton, right, in the first instance. So we're going to have the benzene ring, right, with the oxygen. Remember, there are already 3 dots here, as you can see over here, these ones. That's what I've just represented. So now this particular bond is what I'm going to represent next, which is this line joined to the hydrogen, right? So I'm going to have hydrogen here. Okay, so once that happens, then we're going to have another product plus, you can see this iodine, right, can donate its non-bonding electrons to form a covalent dative bond. So we're going to have what we're not going to have is CH3, this bond here bonded to the iodide. All right, so basically I'm going to have methyl iodide, and this is phenol. Yeah, this is phenol, so I'm going to have phenol and methyl iodide as the two products. These are the products, this one, okay, and this one, the methyl iodide and phenol. So this is a product of this reaction between methyl phenyl ether, this guy, and hydrogen iodide.